missing, well, I know we're missing a few people, but more importantly, the next slide is somebody who's going to give you a special announcement, but they're not here. So we'll have to come back to this slide. So this is the slide. I'll show you the slide, then they'll come and talk to it. This is an opportunity to get him. That's you. You're here. Thank God. Stand up and tell us about it. I made you a poster. I hope you don't mind.
Yes, so very quickly, I'm searching for people for my master's project. The idea of my master's project is to focus on the LGBTQ plus community. If you're interested in doing interviews, doing focus groups, co-designing something together, then hit me up. It would be basically focusing on the issues that LGBTQ plus people face while using digital platforms. And then the final outcome, it would be hopefully an interactive exhibition that would let you immerse yourself into the issues. So it's related to entertainment and yes. So the outcome is kind of open-ended intentionally because it's open for your expertise, whether you are interested in designing a chatbot or designing a game that would let you come in the shoes of a person who has to navigate booking a medical appointment as a, for example, transsexual person. So yeah, if you're interested, hit me up. And
how do they do that?
How do they do that?
Do they have to catch you in the hallway, or could you send me a QR code that allows people to sign up?
So either come to me after the class during the class or whatever. Right. My name is Christianas, or yeah, good point. Who are you? Yes. Yeah. And
okay,
I can
good.
also give a QR code maybe.
Seriously, if you send me a QR code with a form to fill out, I will put it in the last slide before the end of class, because you can see people keep dribbling in.
Yeah.
So you have missed 20% of the class.
True.
So send it to me. We'll do it. Okay, good. Thank you. So, so contact him or wait for the QR code, and we'll get it later. Okay. So I want to talk about the assignments real quick. So assignment number 3, we're in the middle of grading it right now. So some of you have gotten scores, some have not. But I wanted to give you a little bit of feedback on it. Everybody's turned in their assignment now, so I can do this. One thing that I noticed a lot of people missing was that in the experimental setup, the participant is supposed to be in a different place than the experimenter. More than a couple of groups had the experimenter sitting there and the participant here, and like, that's not really Wizard of Oz. That's two friends sitting side by side. It's not quite the same setup. The point is that the participant doesn't actually know what's going on. At least that's the construct. You're not supposed to understand it so that you can get actual performance behavior. That's the idea. Second thing, a lot of people wrote up, said, we learned this amazing thing, and they provided zero evidence for that. So it's one thing to say, for example, that the system has to show empathy. Demonstrate that. In general, when you're doing write-ups of this kind for the class, when you say something that is pretty amazing or requires some support, give the support, right? Give an example, for example. We're not asking you to do full-blown statistics or anything like that, but evidence would be good. And then lastly, we're not going to dock people for this, but the video was supposed to show some of the evidence of the actual interaction, right? So it said in the instructions, show a typical interaction between participant and the system, and a surprising number of people did not do that. So read the instructions. And that's super important. So that's the Wizard of Oz. If you have questions about your feedback or anything, just come talk to me. Happy to do it. So what I really want to talk about is the final assignment. So this is assignment 4. Looks like that. It's a link in the syllabus. And let me plus this a little bit, get this up so you can see it. So handed out today, we will do the final presentations on the 21st and 27th. If you cannot be here one of those 2 days, let me know. We'll figure something out, okay? What we're going to do, so A, as you just heard, read this carefully. Actually read it. Let me highlight a couple things for you. The point of this is you get in a small group. It could be 2 to 4 people. If you have a group of 5, because you have to have a group of 5, just talk to me, we'll figure it out. But no groups of 1, okay? So in particular, if you don't have a group, and by this point in the class, you should have met at least the person sitting next to you, right? You should have met at least one other person. So we'll figure out that group. If you don't have anybody in your group, come to class next time, which will be in 2 weeks, and we will have a matchmaking, speed dating meeting. Okay, so everybody who's already got a group that can leave, and the people who remain behind will pair you up or triple you up or something. Okay, so we want it to be between 2 and 4 people in the group. There's a million topics. I've got a bunch at the bottom of this file. If you can't think of something, let's talk. So in particular, on May 6th, you have to go and fill out the spreadsheet, which looks like this. Okay, so this is just an example. Row 1 is just an example. Oh wait, did somebody fill this out? Did you already fill this out? Good job. So there's an example. You give the title, a short description, what your output is going to be, the people in the group, and there's only 4 spaces here, which is perfect. And then these columns we will fill out. We will either put May 21 or 27 in the date. When you're ready, put the link to your output medium, that is your podcast, your doc, your slides, your video, whatever. Put that there, and put the link to your presentation slides. Because what's going to happen is the day of May 21st to 27th, you're going to stand up, your group is going to stand up and give a 5-minute or less presentation. Okay? 5 minutes is very short, and I will encourage all of you to practice it, because once the clock hits 5, we're in Switzerland. You lose the stage. Right? Boom. Right? You're going to be off. And I will come help you get off. Okay? So what we'll do is I'll make a master presentation, and we'll put it all together, and it will run well. Okay? Then if you make a video, your video should be less than 5 minutes as well. Do not turn a video of your presentation. I already am going to make a video of your presentation. So when I make the master video for this class, you can go in and watch yourself. Okay? Which I highly, highly recommend doing, because there's nothing quite like watching yourself give a presentation. I'm sorry, but it's really valuable. It's valuable skill for everybody. In addition, all of you will be grading each other's presentations. So I'll hand you a web form, and you'll give feedback, and we'll talk about how to give good, useful feedback. Do not give evil feedback. Don't say, it was terrible. Say something useful, like the slides were too small, or the data was too compacted, or whatever, right? We'll talk about that in detail. At any rate, the action item for you now is to start talking with your friends, set up a group. When you're ready, go in and put your group data in the spreadsheet. And if you don't have any good ideas, talk to me. There are a bunch of ideas here at the bottom. And throughout the course, I've been saying, think of this for a research project, right? I've been saying that every single class. You should have at least by this point 14 good ideas, or at least 13 good ideas and 1 terrible idea, or something. So if you want to build something, that's great. We've had teams in the past build models of games to play. We've had people build models of me, which is slightly frightening. Anyway, okay, is that clear? We'll come back to this when we come back in a week and a half from today. Okay. Also, if you want to build something, first off, a really easy, I'm just giving you a hint here, a really easy project to do is do compare and contrast. So take like 4 examples of image generation and then compare and contrast on the same test set. Talk about what the differences are, what the advantages are, and so on. Okay, back to our topic. There we go. Okay. Yes, ma'am.
Yeah, so on the Google Sheet, how do we know which in the order, which group will be presented on the first day?
I will, yeah, that great question. How do we know what order groups will present in? Once they're all in, what will happen is that some people will say, I can't possibly be here on the 27th. We will put them on the 21st, and so I will fix the order. And every time we've done it, we've managed to get everybody in. But it requires 5 minutes presentation, okay? And it's actually really helpful to you, because once you give your presentation, then you'll get not just my feedback and Ibra's feedback and Izya's feedback and Chat's feedback, but you'll get the feedback from everybody. So you get a bunch of content, a bunch of really useful information for you. Okay? All right. News you can use. Another question. Okay.
So in the suggestions, like there's a compare and contrast, there's a build, I think, there's a pilot. So will all of them be graded? Like, are the requirements different for, let's say, a pilot versus a?
We can talk about individual projects in detail. No, they're kind of all the same. So, but by the nature of the task you're doing, they will be different. So, for example, if you're building an AI system to do, for example, visual recognition of different kinds of cats and dogs, that would be very different than doing a compare and contrast of image gen systems. Yeah. And like I said, I'm totally happy to talk with you to flesh out and sort of specify what your project should be. Nobody should come to me and say, I didn't have enough direction. I'm willing to give you lots of direction. So, okay. The point here today is I actually want to click through on this, because this is Ethan Mollick, and if you don't follow him, I actually recommend this. In the very last class, I will talk about how to stay up to date on AI and HCI and so on. But Ethan Mollick is one of those people I follow. And what this very funny GIF is doing is it's showing how to use the new agent Manus. And what he did is very clever. He actually made a post a while ago, and he gave a screenshot to Manus and said, could you do this project? And it actually did the project. And it actually opened up a separate panel and agentically wrote the code to do the visualization and then published it as a web app. Damn impressive. It's worth looking at. So you got the link to this in your slide deck. And we'll talk, I guess we don't have any more time to talk about Manus, but it's one of those up-and-coming agent systems that's worth tracking. More generally, I would link in, follow with Ethan Mollick. Okay, so, all right. So that was that. That's the quick update news you can use. Now let's turn to the topic of today's lecture, which is computer perception systems generally. And we've got a bunch of capabilities. We've seen some of these already. Remember when we did the interactive demonstration where you built a visual classifier? Remember that? So that's an example of a perceptual capability that the AI system has that can do something for you. Right? So you've got Google Lens, you've got all these different kinds of systems. And today is kind of a sampler of a bunch of different perceptual systems that either have a front end or need one badly. And so I'm going to walk through a set of examples, including some perceptual modalities you might not have thought about. Computers that smell? Yes, we can do that. So let's get into it. So audio is one of those things where it has been on the cusp of working for a long time. And then, of course, a few years ago, Shazam came out and SoundHound came out. Those song recognition systems. So you can basically say, what's this song? You're in a club, you want to play it. And if you've ever tried to do that in a real club, it only kind of works, mostly because it's really noisy in there. And this is a huge problem still for the recognition AI systems that are out there. So there's a system called TunePal that I want to point out to you. I'll show you a quick demo. It's a kind of example of where the cutting edge of AI research for the front end for tune recognition systems is. Now, whenever you hear an AI system that does something, you should always ask, how much of that thing can it really do, right? So the question here is, if you use SoundHound, you probably have noticed it doesn't work well in live performance. It works well for recorded performances. So if you're sitting at home and there's a song comes on, you can do a reco and it probably will get it. But it probably will not recognize the entire oeuvre of 16th century art songs. Sorry, it wasn't trained on that. How do you know? The only way you know is you try it and fail. So here is an example of a system called TunePal, which is built by students at the University of Dublin, I think. What it does is it recognizes live performance of Irish folk songs, folk tunes, okay? Now, what I'm going to show you here is the video that I made of recording an Irish session, that is, a bunch of musicians sitting around playing, and I'm sitting there in the back thinking, I don't know this song, what is this? And there's no way to find out. So I'm stopping somebody and saying, what are we playing? And then he'll say something maybe, and then, or most likely, you just learn the tune, you never figure out the name. So the problem with it is that, as you know, SoundHound and things like that don't recognize folk songs, and they don't recognize multiple instrumentalists playing live. So here's the setting. So I'm sitting in the back, hold up my phone, I'm recording this. I have no idea what I recorded that. Now I'm playing the back on my phone through my computer, which is running TunePal. I'm sitting there in the section. It's still thinking. We're trying to pull out the melody out of that raspy sound. And so now it's submitting it to the server. It says, TunePal thinks it's called Lafferty's with 53% confidence. This is the MIDI version, so it's clearly the same. It's even in the same key. So this works over the entire catalog of roughly 1,000 or 1,500 different traditional Irish folk songs that would be played in Irish sessions. So that's the kind of music you'd hear if you walk into a bar in Dublin on a Friday night. Literally hear that. And that's the way you find out what's going on. Cool. There we go. Yo.
Do you know how this works? Because it can't be fingerprinting.
Correct.
Different templates, different.
That's absolutely correct. So the question is, so how the hell does it work, right? And not fingerprinting, which is the way SoundHound or Shazam work. What this is doing is it's actually extracting the melody, and then so it then represents that as a MIDI sequence, and it's got all the other tunes represented as MIDI sequences, and it finds the best match. And what it will do then is basically all of these tunes have a particular fixed length, and so it compresses it, does a little bit of time distortion to make sure it fits in there, and then does a comparison. So it's a basically pattern matching system that uses basically strings of characters representing the song. It's very clever. There's a link in there. You can go read more about it. Now, speaking of recognition, as you know, we have pretty phenomenal speech recognition systems. And when I was a graduate student sitting in your chair, speech reco was a dream. It didn't really work, or worked particularly in only perfectly recorded situations under limited vocabulary, and then even then, sometimes not. And then when I went to Apple, it got to be decent, and the error rate was about 15%, which is not really excellent. In normal human speech, we're looking at an error rate of around 1% or less. So to actually work, you need a very accurate recognizer. And now, of course, speech recognition systems are pretty good. We've got these speech-to-text systems. They're pretty noise robust, and Google and the API offered there has got, I don't know, 40 languages, and it's probably got more by now. And every year, these things get better and better. to the point where very shortly, you will see speech recognizers that are better than humans, meaning they will work accurately under high noise environments. So, for example, if there's all of you are speaking simultaneously and somebody's talking to me, my error rate's really high. These things will now have the ability to focus in on an individual using, say, acoustic beamforming and just pick up what you're saying out of the whole thing. Right? So this is an area where AI has gotten a lot better over just the past few years.
I think they're already better in picking up different accents. Let's say
Yeah, that's true. Yeah, your accent would have been a problem 5 years ago, right?
Yeah, for AI, but
For-
now it's a bigger problem for maybe some people who have never heard someone
Yes.
like me talk than AI.
That's true, absolutely right. So the accent problem, and I will tell you the way the accent problem got solved, it's kind of no surprise, more data, right? So basically what happened was when I was at Google working in the search and we were working on this, my boss was Israeli and it didn't recognize his voice at all. I thought his accent was fine, but for whatever reason, he had basically 0% reco. It was terrible. And so we kept gathering more data on Israeli accents, Indian accents, African accents, Chinese accents, the whole 9 yards. And finally, we got enough data that we can now just recognize this all. So, which is particularly interesting. Have you guys seen the Scottish elevator YouTube video? Okay, you know what I'm talking about? Okay. It's funny, but it makes a really interesting point. And I'm sorry that people who couldn't understand the Scottish accent. It makes the point, right? Any case, so it's gotten much better. We no longer have problems with Scottish accents, at least in Edinburgh and Glasgow. Get farther north, I don't know. Okay, so speech is great, but I want to talk a little bit about the conversational aspects. And we've seen OpenAI's ChatGPT in its live mode. And I want to show a slightly different version of this. This is a system called Sesame. And what I want you to notice are the fluidity with which the conversation goes back and forth here.
Hey there. Looks like a fresh batch of good vibes rolled in. What's brewing?
Wait, what? Say that again. I didn't quite catch all the references.
My bad. I'm still getting the hang of this whole being concise thing. Basically, I was just saying hello and asking how you're doing.
Oh, okay.
What's on
Thanks
your
for
mind?
simplifying it for me. Yeah, well, nothing much. I just wanted to chat a little bit. I recently moved to the United States, and I'm feeling a bit disoriented. I'd like to get to know people, but I don't even know where to start.
A fresh start in a new country. That's a big leap. I can only imagine.
So a couple points. The response back was very fast. That was under half a second before the voice came back. So that adds to the fluidity of conversation. Also, later on, you'll see that he has barge in. Remember barge in?
You know, sometimes the best way to get those bearings is to just hop in and see what's what. It's
But
kind of
what,
like
what
trying.
does that mean, to
For
hop in
example.
and see what's what? I mean, that's a kind of a broad statement. What specific things do you think I could do?
You're right. Hop in is a bit vague. It's my bad.
It's all right. Don't worry about it.
So it's pretty good, right? The speech recognition is pretty good. We're going to talk next, lecture after next, about speech synthesis. This is in the U.S. would be perceived as a black accent, which is particularly interesting. You can choose among many different voices and styles and genders and all this kind of stuff. So I just wanted to point this out, that the speech recognition and conversational systems are quite good now. Now, olfaction is interesting because for a long time, in fact, to some degree still now, how people smell has been a little bit of a mystery. And basically, here's a nice paper that talks about olfactory representations. What does it take? And basically, your nose has this incredibly dense set of receptors, but they don't recognize everything. And different people have different sets of different receptors. So we all have a slightly individually tuned sense of smell. If you're trying to build a computer that does this, you're trying to build, say, a robot that finds all kinds of interesting problems, you basically build a sensor. Oh, do I have a picture of it? No, I don't. Darn it. What I'm trying to point out is that what we have is a sensor which has all these different sort of molecular receptors on it, and you can detect the degree to which a particular kind of macromolecule is coming over those sensors. And you get one of like 1,000 different kinds of detections of molecules. The scent is then a collection of combinations of those particular molecules. So vanilla, for example, the smell of vanilla is a combination of like 5 different scents, 5 different individual molecules. It's not a single molecule. There's multiple things going on. Wine, for example, any particular wine has a whole different set of particular macromolecules you do. And so what we can see is that we can actually build models not just of human sensory apparatus, but also of dogs or of insects or so on. And so what we can do is build these systems, these neural nets, which then can classify smells. That's one thing. Second thing to note is that smell is also a highly cognitive activity. Your brain, so for example, when I was walking outside the other day, I smelled a lilac bush. And it reminded me of my grandmother rather, who had lilac hand lotion. Okay, that doesn't happen in your neural net, but it happens for people. So, can we design a UI for scent? There are some systems that are purporting to do this now. So they have a collection of these little reservoirs of all these different macromolecules, and they will then blend them to create the scent of, say, eucalyptus forest, or the scent of a diesel train, or whatever. So I invite you to think about what an interface for that would be like. There are lots of different kind of perceptual things we can have, and I want to talk about some other ones you might not have thought about. So for example, we think about cameras as seeing ordinary light. But in fact, as you know, light comes in a wide range of spectrum, right? From very short wavelength to very long wavelength. And what we can do is take a camera which can see in those different wavelength bands and combine that imagery to do new kinds of analysis. That's called hyperspectral imagery. And so you have a camera that, for example, will look at people's skin and can see different kinds of skin conditions. So for example, your dermatologist probably has a little ultraviolet light. They walk around and look at, oh, that's cancerous, right? That kind of thing. This is doing it at the camera end rather than with the light end. So there's also all kinds of things one can do if you actually take the visual image and do various operations on it. So for example, we have LiDAR and sonar, which are basically raster-based representations of the world using different kinds of sensing apparatus. So LiDAR is looking at the return time for light bouncing out. Radar is the same thing for radio is. What else could we do? I love this image. This is from a paper. It's linked in the slides. You should notice this face on the right. That's not an artifact. This is color amplification. Color amplification is taking 2 frames, looking at the color differences between the same pixel, and then stretching the color gamut. So that if you have a light pink going to a slightly different shade of light pink, you then take that color space and move it out like that. And all of a sudden now humans can see the time varying color behavior. In this case, the flushing of the face is the baby's pulse. So there are now devices that can actually read your pulse without touching you, right? That's thing one. Thing two is, it's a little hard to see here, but see how the head is moving up and down? Same thing with motion amplification, okay? Why do we care? A, you can now start to diagnose all kinds of things that you couldn't see before. So for instance, if you look at a building and do motion amplification, you can see, like look over the course of a day, you can see the building swaying back and forth in the wind. So it's the same idea as color amplification. You're just stretching the space here and doing that over time. In particular, for the baby, it's not such an important consideration, but for adults, you can look for things like essential tremor. So when you put your hand out, steady. You think it's steady. It's not steady. If you look at very fine detail, you'll see there's a little, I'm going to amplify it. Looks like this, right? And what happens when you say your grandparents develop essential tremor is that the neural circuits that control that start to fade away. And that allows the essential tremor to be amplified. We can use a technique like this to look for early signs and symptoms of that. So all of a sudden now this AI-based image filtering and monitoring can open up all kinds of new things. So let me ask you, let's spend just say 3 or 4 minutes talking with your neighbor about 2 things that might be interesting for you, for computers to perceive. I've given you some examples. Generate another couple examples. Okay, what would you do? Go. Okay, everybody. What have you got for me? Tell me something new and interesting. Got any good ideas?
We discussed many animals a lot because some animals are worse than human in detecting color, for example, but
Yes.
are better at something else. And with technology, you can combine everything. Like you can
Okay.
see as a human and as a bat, as a dog, as a whale.
Okay. That's great. So emulating different animals' visual systems, for example.
And combine them.
And yeah, okay, great idea. Anybody else? Another team?
Taste.
What do you got?
Taste. So, taste.
Taste. Yeah, right. So,
basically it can,
right.
let's say, just have its own sensors. Like I I wanted to suggest me a drink and it can try all the drinks. Or
Very good. Right.
Suggest me something with the correct sugar level, the correct sparkle level, the correct
Right. Right.
aftertaste.
Very good. I mean, you mentioned sparkle level. That's more than just taste. That's actual physical action, the little motion sensor on your tongue.
It's about chemistry plus taste.
Right. Exactly. So that's another combination idea. Very good. Anybody else? How about you guys in the back row here? Come on, back rowers. What do you got? We were talking about archaeological uses. You know, using a scanner in the bottom of a pyramid and looking up to see, you know, potential voids in the space, which is, you know, another interesting. Yes.
So there are actually systems that, from a voice, can distinguish whether a person is sober or intoxicated.
Okay. Yes. Okay. We don't need AI for that, but yeah, good idea. And team.
This relates to the smell example from earlier.
Yeah.
I think, for example, most allergy dogs work based on smell.
Oh,
right? So we
yes,
can develop
yes.
tools that can replace that. You might be able to help people
Yes.
that maybe cannot afford to have a dog to detect allergens in food.
Oh, that's an excellent idea. So something like that. You got one?
Emotions?
Emotion. Yeah, that's a great concept. People have been working on that for a while. In fact, there's a company called Affective Inc., AFFECTIVE, and they've been trying to do that, exactly that, because wouldn't it be great to see if somebody's pissed off at your UI? It kind of works. It's still in the experimental stage. That's all great ideas. Thank you.
I think the emotions is also like brain electrodes and brain systems.
I'm not going to talk about brain-computer interfaces, but one could. It's a really interesting, as a whole class. Yeah, absolutely, absolutely. Okay, so let me tell you a couple things that you might not have thought about. Remote sensing, for example, right, using satellite imagery. And so I ran across this paper a couple years ago, and it just stunned me, where these people in Germany used Google Earth imagery, and they wrote a cow detector. Yeah, you can do that. So they wrote a cow detector, and they looked at the alignment of cows in the field, and this is an amazing chart, right? Basically, it shows us that for a standard time, you know, say in the middle of the day, when you've got nice imagery, most cattle are pointing kind of slightly north. They're pointing in particular along with the magnetic north, wherever it is on Earth. And so, if you look at this one, you can see there's a couple of variant cows here, but they're all kind of aligned, which is an amazing result. And when you start to take that idea of looking at different kinds of imagery signals, combine it with the notion of longitudinal data analysis, which gets right into classic, you know, AI topics, we can start to look, for example, at the growth of deserts and how they change over time, or how particular vegetation takes over a particular area or not, because you can start to use these multispectral images from Earth imagery over time. Okay, so we've got three ideas all going on here, and then you use standard AI image recognition techniques to start to understand this.
The new DJI Neo could change drones forever. Here's what.
Stop. I'm going to show you this. It looks like a little ad, but it's just a video. It's just a TikTok of this guy demonstrating this little drone, which is kind of cool. And what I want you to take note of is two things: the UI and what it's doing. So the AI here is it does image recognition in real time to find him, and will then track him, and as it plans its motion through space.
The new DJI Neo could change drones forever. Here's what. So you've seen DJI drones before. You've seen that they can shoot beautiful 4K ultra-stabilized footage, but what you haven't seen is this. Hey, fly. This drone doesn't even need a controller. You can use a remote or a motion controller or the phone's app to manually control it, but even without that, it has 6 different quickshot modes. Like, for example, this front follow mode, which locks onto your face kind of like a paparazzi. Or circle, where it literally does a 360-degree lap of you and records a clip of the entire thing. That is just insane. All right, you can take a rest. It's also got full coverage propeller guards to both stabilize the drone and also protect it. But here's what I think is the smartest bit. You can use this to record vlogs. See, the problem with drones is that drones make a lot of noise. And so if you stick a microphone on your drone, all it's going to capture is So what DJI have done is allowed your phone to capture the audio and remove that background noise, and your drone to capture the video.
So there's a bunch of AI in there, right? There's the voice, the background noise removal processing step, which is a lot of signal analysis, but also a lot of what we'll come to find out is called outpainting methods. Then there's the image recognition, the motion planning, and the UI is just voice. I mean, there's a AI app, a UI on the phone you can use, but you can just pick it up, turn it on, and say, "Go, follow me," and it will just follow you around. Or you can say, "Fly a circle," at which point it then has to figure out how to fly a circle around this object that the image of which is changing constantly, right? So there's a bunch of AI going on, packaged up in a very simple to use interface. And there's another one. You can watch.
This is the easiest drone to.
Yeah, I know. We already talked about that. It's worth watching that video because it shows actually the error condition, because he at one point runs to the side and you see the drone following him, and then it keeps going a little bit and slams into a tree. It's like, yeah, you still have to watch out for that stuff. So the point, in some sense, of today is to talk about computer perception in all its different ways, and the ways in which we as humans can use that and understand it. So the fundamental question, I think, for a lot of this is, how much do the users understand about perceptual systems in AI, and how do they control them? So you know about this, right? This is, I don't know about you, but I use this in translation function almost every day when I'm looking at something, and it actually does live image recognition, detection, translation, so on. You get a lot of these on mobile, of course, and of course then you can do image search for various kinds of similar images. I can speak to my devices and say, play something complex, and it'll do the right thing. So in general, computer vision has gone through a huge sea change in the same way that a lot of the AI applications have changed recently. In the past decade, we've gone from barely able to process an image to being able to process, label, alter the image, all in pretty easy ways. So there are things like depth maps and heat maps. There's lots of stuff going on. Another kind of image recognition thing is you've got, this is a literal email I got the other day, and there's a lot of very funny German words in there, and I can sort of understand them, but I can just click on translate, and it does a decent job of translating it, including all those funny long special words. And of course, in the upper left corner, you see the summarize this email, and it creates a pretty decent summary, even though it's going from German and then giving me the summary in English. So it's pretty good. So this is, I want you to notice the UI for this. So the UI here, oops, let me back up. The UI here was just presented as an option. Translate to English, because I've set my default language as English. So this is not hard stuff, but the UI designers at Google spent a lot of time figuring out how to get this into Gmail. Think about just, erase what I just said told you in a set for the past couple of minutes. How would you design this? What would you do? Because you don't want it to take up too much space, don't want it to be too prominent, but you want it to be available when people need to access it. So that was what this solution is. Blue text, a little icon for the translation icon, and an X button so you can get rid of it. Always include the X button. Always include close. And then once you do that, yeah?
Do you know what's the reason? Because summarize this email is also from Google.
Yeah.
Why they separate from translate? And the summarize this email does have X button.
The real answer, I will only tell you the truth. Two different groups. Two different sets of UI designers, right? These people were part of Gmail. These people are part of Gemini. And so they could, but they'd have to work with these people to do it. It's much easier for them to just stick it up there. That's the truth. Is that good design? No, it's not. So actually, I would have preferred to see that in the same point. So you have a set of options.
I think there might be also the local issue, because the translate might be available in a wider range of countries.
Yes.
Compared to Gemini.
Yeah.
And then there would be cases where.
Then there's that. I don't know about you, but every so often I run into some kind of AI function that says not available in your country. Pisses me off. This is why you have VPN. So if you don't have a VPN, you should get one. There are free ones out there, or very cheap ones. In particular, because since I'm dealing with like financial stuff back in the US and it will not run if I'm here in Switzerland, I have to VPN somewhere in the US. So it makes it look like I'm in the US and so on, right? So, but that's correct. That's absolutely right. So you've probably all seen this. The latest ChatGPT Studio Ghibli transformation. So this is me giving a lecture in that style. And so once you start down this path, the AI processes go wild. You can start to do Van Gogh or even Botticelli. So there's a lot of, we're going to talk about this kind of transformation in 2 weeks again when we talk about artistic development. But I have to admit, that's a pretty good picture. It's better than reality. So I want to spend a couple minutes talking about image understanding in lots of AI products. So we've seen it in the Gmail thing where it's actually recognizing the boundary itself. You can search by image. You probably know about that, right? You take an image, import it into Google search, say search by image. Bing will do the same thing, very nice. On your phone, you can search to tap. You can actually be looking at something and then double tap on the thing and it will, if it's on an Android phone, it will allow you to search for that thing that's in the visual field. And Google Lens is a really handy thing, which if you don't use it, you should learn how to use it. I'll just recommend that. So it allows you to look at a picture and then say, identify what this thing is. So here I've, for example, looked at, on the far left, this lily. What is this? And identifies it. What's this shop? Identify that. This is the third one to the right is the handiest thing in the world because your Wi-Fi router has a barcode on it. It will record the barcode and do the install and set it up correctly. Or you're being able to take a picture of some text and then have it OCR it, do the translation, et cetera, et cetera. So there's a lot of stuff, and it's built into things like Google Photos or Facebook Photos, whatever, that do recognition in various forms. Now, even though this works for Oliver, it's terrible about recognizing dogs in general. It can recognize some, but it doesn't do great breed identification. And trying to recognize your dog, which you can do, probably can't do. Dogs are just too similar. They're just, unfortunately, very, very similar. And we've talked a little bit about some of the other AI applications that are out there. So for example, we talked about the Nest camera. Remember that? The one that would grab only the best video clips. You would just set it up and let it run 24/7 and would then return a library of the best video clips. That worked, but as we said, it didn't work well enough to actually earn a place in the market, so it's not available anymore. And you probably have seen these magic eraser things. Has everybody used that? Has anybody used that? Okay. Okay, the rest of you can do this, right? I'm just telling you. You can go into your favorite application and go ahead and start to collect items in the image and make them go away or blur the background by itself. You could do this in Photoshop. It was a major pain. You had to learn all of Photoshop. You had to learn about radius of pixel movers and all that stuff. But now it's all automated with AI. And I'm going to show you this video clip because this is from Andrea's lecture yesterday. And it illustrates this point really well about integrating AI image reco into products. So this is the clip that she tried to show you, and you'll see at about 1 minute in where the AI system says, oh, I can't do that, because it looked at the Figma mock and recognized that that option had not been fleshed out. So let's watch and I'll point it out.
Can record payment and settle up with my friends.
Okay.
Yeah, and that's it.
Which of the three options on the welcome screen would you select and
That's
why?
the AI.
There is add your apartment
Human.
option, which is something that's not relevant to the study. I can see group trip being one of the options, but
Okay, so let me point out, this is an AI moderated study. This is the UI that's under study. This is the person that's participating. So this is the person who's a participant in the test. They're zoomed in. This is what they're seeing. This is what the AI is doing. Now listen to what it does next.
We'll go ahead with skip setup for now.
Gotcha. Can you share why you chose to skip the setup?
It's just that I don't know the app. I don't want to invest my time in setting up, only to realize that it's not useful to me.
Thanks for sharing that, Shrey.
Okay.
Please go ahead and continue with the task.
So I can add expense, I can start a new group. So I'll go ahead with starting a new group. Yeah.
Sure. What are your thoughts on the screen?
Yeah, I think I'll try to add an image, but I'm not able to add an image here.
The photo option isn't clickable in this prototype. Can you go ahead and name the group and select the text?
Okay, it knew from not having any code attached to that option, to the camera icon there, that was the option for selecting a photo, even though it's not declared inside the Figma mock. So this is analyzing the mock in order to be able to interpret to the participant what's going on. This is very, very clever. So let's take our 4-minute break, 4-minute, 30-second break, and come back at 9. All right, and I'll leave you thinking about that.
I can record payment and settle up with my friends.
Okay.
Yeah, and that's it.
Which of the 3 options on the welcome screen would you select and why?
There is add your apartment option, which is something that's not relevant to the study. I can see group trip being one of the options, but I'll go ahead with.
Sure. I'm going to get to the next slide. There we go. Yeah.
So recently I saw this article, maybe you saw it too, about Tim Cook saying they're going to focus like 100% on the AR glasses now.
Yeah.
And they want to release it before Meta does it. So I actually think it's a good idea, but the problem is what I was thinking, like, in terms of the usability.
Yeah.
So how are you gonna write text? Like I see for the Vision Pro that you can like tap with your fingers, for example, and you can like look at the letters, which is actually working pretty good.
Right.
But it's like not fast enough as like typing, for example.
Right.
And communicating, like you said, like it's working, but in some situations you don't want other people to hear what you're writing.
Right. Right.
So how are they gonna figure that out? Like how?
I don't know, actually.
You don't know.
I don't have any particular insight into that. I do know that they've got the eye tracking thing working pretty well, which is great. And then doing the gestures, that's working pretty well. And the problem is, speaking aloud is always going to be audible.
Yes.
However, I know that there's other work going on in sub-vocalization recognition. So you could mouth the words, say, obviously, right? And it will recognize what you're actually trying to say, and then converts that into speech. And that's a lot harder for anybody else to pick up on. So that's an option.
But do they need? I've seen that too, but they have like some kind of device like around here in this area.
That's a different solution.
That's a different.
Yeah, it's a different one. So there's a couple different ways of doing for brain-computer interfaces, and that's a version of that. Mm-hmm. The one I'm talking about actually has a little radar that's actually looking at your mouth and musculature in your throat to figure out what it is you're trying to say. So you're making the A sound, you're making the R sound, you're making the T sound, right? And then it puts that in together.
Yeah.
And it works. Yeah.
So do you think they're gonna figure it out?
Yeah, I think so. I don't know when. I don't know if it, I mean, I think
if they want to release it early, they may probably in the next couple of years.
Well, Meta's already got a product out there, right?
Yeah, that's
so
the thing.
So they can't beat that. So I'm pretty skeptical about this whole realm of glass augmentation. As a professional glasses wearer, right, I'm not sure I need more layers of stuff interfering between me and the real world. So it's the kind of thing I think demos really well, but it's difficult to adopt in real time.
Because I've tried the Vision Pro and it's pretty impressive.
It is.
It's just
right.
not very usable. It's like not for the mass market. It's just
correct. And that's where you need 1 billion people to buy it. And Vision Pro is not that not that thing. It's still too heavy.
Yeah.
So I do believe glasses will be useful, and Vision Pro is useful, just not for a billion people, right? So it depends on how you define success. It's cool though, right?
It is cool.
Yeah.
But actually, read recently the book from Johnny Ive. Have you worked with him?
Yeah.
Okay.
Yeah.
And I also saw that he has his own company now, and he's designing his own stuff, and he's working with Sam Altman.
Yeah.
On a product, and the OpenAI is supposed to buy it now.
Yeah, that's the last I heard as well, is that they were going to buy it. The last I heard, though, what he was working on was basically the same as the Humane AI pen. Remember that?
Also like the little thing, yeah.
The thing, no interface,
Yeah,
just
yeah.
press, that did not do well in the marketplace, right? Got terrible reviews. So it could be an instance of it needs to get accepted by the market, and a subsequent version will succeed somehow. I don't know. That's a hard one to call, but I think that's what he's working on. I think that Sam Altman wants that not just for the AI capability, but also for the person tracking data.
Oh, okay.
Right.
That's smart.
So something I almost put in the news today was that OpenAI just announced that they want to build a social network.
Oh, really? I've not seen it.
That was brand new as of today.
Wow.
They want to compete with Facebook, and they don't want a social network, but they want all the data from it. Right?
Wow.
So
that's interesting.
It is interesting, yeah.
Thank you.
Yeah, sure. All right, let me show you this accessibility feature. So one of the big domains for a lot of this kind of work with the vision and the AI recognition, all that kind of stuff, is helping people who are not as enabled as you are.
Cook time. Pizza. Power level. Add 30 seconds.
So what's going on here, I'll show it to you again. This person is pointing to things in the microwave. The glasses or the camera is recognizing what they're pointing at and speaking it aloud to the person. So if you have low vision, you can actually operate a microwave just by doing this. You can do it with your eyes closed, basically. That's the time, right? I'll play it again.
Cook time. Pizza. Power level. Add 30 seconds.
So this is actually not that hard to do, because what you would do is grab the image, right? Do the recognition of all the items on it, do a little bit of item identification, and then whatever they're pointing, just do the difference. So that's
cook time
for a while. And in other areas, there are AI systems to help modify, for example, the contents. For example, this is a product called RealTone from Google, where different colors of skin render differently. And so basically this is an AI hack for the system to basically adjust the color levels in the image so that people with darker toned skin will read more accurately. So there's a bunch of work like that, and you can see this is sort of before and after. Dramatic difference. So real question for HCI people now, when you think about it, how do you control this? Is this a sub menu under settings? Or how do you make this available? One answer could be this is under voice control, but then you have to know the name of the feature, right? Turn on RealTone, turn off RealTone, that kind of thing. So, or do you get a slider? This whole realm of image understanding is super important for all kinds of reasons. If you're an advertising business, like say YouTube or Google, there's all kinds of image processing that goes on to, for example, shorten images or highlight logos or do manipulations in order to make the ads work better, right? So there's a whole team at YouTube that does nothing but this kind of thing. Or as you see over here on the right, changing the size of ad displays. You can't just scale it up. You actually have to do some processing to make it work. And of course, collecting data from the world is really important as well. So you might think OCR is a solved problem. It's not, because you get images like this. So when the Street View cameras go around the world, they get all these different kinds of images, including terribly degraded ones like that. And you want to be able to extract that information. So there's a bunch of work that's gone on to OCR, optical character recognition, including working in multiple orthographies. So we have Chinese recognizers, Arabic recognizers, and on and on. You've probably also seen this in Google Maps. So there's now an AR capability built into Google Maps, where what it does is it has your GPS location, but which direction your camera is pointing is mapped and recognized with respect to the imagery already collected at that location. So here's the map overlaid onto the real live imagery, along with an instruction saying go this way. So this is AR in your phone, basically. So when I'm walking around town, if I'm, say, in the Altstadt, I can hold it up, and it will show me the live image overlaid with where I'm at and what the walking directions are. And of course, if you're building a self-driving car, it's important to recognize all these things in that world. So, this is actually near where I live. I didn't know that. Who knew? Anyways, my street's just around the corner. This is just a sample image I got with labeled objects in it. And so image understanding is really built into all kinds of things, from self-driving cars, through directions, through maps, through advertising stuff. It's in a lot of stuff. So if you're going to be an HAI practitioner, you need to understand what's possible. And so if you're interested, project idea, you could go explore the Google Cloud options, the APIs for that, if you want to build a simple image recognizer on your own. We were talking in the back earlier about what else could you do? You could do image diagnosis for various kinds of medical conditions. So for example, here, a healthy and diseased retina, where it has identified the location of different hemorrhages. And you can spot them because these little fan-shaped things like that are all hemorrhages where the blood is leaked out into the retina. And there's a huge amount of work going on in cancer identification. And here it's all highlighted in green, but if you didn't have the highlighting here, you and I would look at that and go, it looks the same to me. So the trick is, how do you get enough training samples so that you can build up a recognizer based on the imagery alone? Or here's another really nice example. This is a case study of a radiography application that finds bone breaks in children. Children's bones are not the same as adult bones. And a problem with it is if you're looking, for example, at this 8-year-old foot, it's difficult to see if those are actually, if they're supposed to be like that or if they actually are broken. Because children's feet look sometimes like they're broken when they're actually not. It's complicated. So if you buy this product, right, you too, in your little country hospital, can have an expert looking at the x-ray of a child's foot and saying, this one's broken, this one's not. One thing I like about this UI is, you see the question marks up there? The system is saying, I think this is broken, but I'm not 100% sure. Indicating confidence levels is really, really, really important. And so this is one of the, most medical AI systems will indicate confidence level in diagnosis. But this one makes it nice and visual on the UI. And it works really pretty well. So the AI achieves a sensitivity of 92%. That means it caught 92% of them. Very specifically, and it's an improvement of 4% over expert radiographers, experts in the area. And importantly, it increased it reduced the fraction of missed fractures by 29%, which is huge. Again, if you're in a small, remote hospital and you don't have a person who's expert in looking at child x-rays, This is really helpful. And now you know how these things are built, right? You build a classifier, you train it on 1 billion examples, you have humans labeling them all, and you get decent results. But there's more. There's more. There's more to computer vision than just recognizing, classifying images. There's 3D reconstruction, which is used obviously in Google Street View, but also used a lot in archaeology, for example. You take a bunch of images and then you do 3D reconstruction to figure out the shape of that pyramid, or the shape of that tomb, or the layout of agricultural lands in the Amazon. There's a bunch of VR, AR applications that are coming up, along with various scanning applications. Now, a really huge area for AI and image processing is classification and labeling. And the big question for a lot of these is this an X or a Y? Is this a cat or a dog? Remember we did that example earlier? So what's that? As you now know, it depends on how big your label training set is. So if you have a bird or flamingo in there, you have a decent chance. But if you're only doing cat and dog determiners, then it's not going to work. So we have binary classifiers that say it's a cat or not. And we also have these multi-class ones. And the good multi-class classifiers will tell you, I think it's this with other probabilities. That's what we're seeing here in that bar chart. It's either a leopard, upper right corner, or a jaguar, another possibility. It's giving you alternative explanations. So we can build systems like this that do classifications along with estimates of a likelihood that it's true. So how do we do this? There's a bunch of packages out there that will do this, but basically what it's going to do is take an image, like the 2 cats on the left, and do semantic segmentation. That's the first level of operation. Can you segment this image into pieces that are X or Y or not X? So that's this nice picture here, where you see all this complex imagery here, and it's managed to segment it into reasonable components. Okay, that's pretty straightforward. That's a little harder. We've got a blob here, and a bunch of stuff in the middle. It's not a bad estimate, but now you have to do another layer of processing. So we do this segmentation, and then we take the segments and then try to recognize those, rather than trying to recognize the whole thing, right? So it's a breakdown from the image whole to the image segments to the classified thing. So that's why we are able to build things like this that identify cars and dogs and see the probabilities attached and so on. Now, I bring this up because we have all this technology to do that, where we can take images and start to segment it and then identify the centers. Why do you want to do this? This is really valuable for motion analysis. If you're looking at a video of something, you want to be able to track the centers of those things using the hourglass network, and will actually then find the centers, and you can track that over time. Pose estimation is used a lot in games, and there was, for people who might want to do research in this, there was a system called Kinect from Microsoft. Does anybody know about Kinect?
Yeah, that's my favorite thing.
Yeah, it's very awesome, right?
Yeah.
Basically, you point it at something like this, and it gives you back the poses, the estimated poses. I don't think it's still supported. But anyway, there are pose estimation systems out there, and you can buy them sort of off the shelf. Again, I'm trying to show you capabilities. So this isn't the next level of analysis up. So it does the same process as before. Detect the objects, segment, and then start to look for key points in the articulation, the skeletal frame. So same thing here. We're doing detection and segmentation as a precursor to labeling and then doing whatever it is we want to do with it. So there's a lot of ways to do this segmentation. There's a thing called monocular depth estimation. This is really good, especially when you have things moving around in the scene, where you have a model for what the scene, say a city scene, would look like, and you then start to estimate the depth. Taking that depth map along with the image segmentation, which is in image and color space, now you can combine them and do really very good sort of estimations of what the objects are in the scene. Another nice analysis that was done was by looking at people in videos. And this is an example that was done a few years ago where taking 440 hours of video and then doing this kind of analysis of it. So identify faces, doing all the processing we just talked about. Identify the faces and then label each of those faces by perceived genders, whether or not they're speaking, skin tone, perceived age, and so on. And what you can do when you've got data like this, just like with the cows, you can extract remarkable things. So this analysis over here shows over time, since 2010 to 2022, the relative, there's a regression line here for female characters. So this is doing data analytics for you. And if you're in the realm of user experience research for a large company, you don't have to do this one in particular, but you see the kinds of things you can do. You can take large collections of data and build classifiers and analytics for them like this. Image retrieval, right, is pretty straightforward. What people do, it's not straightforward now, it wasn't 10 years ago. You've got a query image, you then create what's the word I'm looking for? The vector which describes that thing is called I'm blanking on the word. Anyway, a signature, there we go. You create a digital signature and then all the things that are in your database already have pre-computed signatures. So all you're doing is comparing these long signatures to each other. You don't have to redo the analysis at retrieval time. That's the trick. But your signature algorithm has to be robust, okay? It has to be invariant to rotations and color shifts and all that stuff, okay? But once you do that, you can then do a retrieval against that set and retrieve some pretty good near hits. And of course, you see this all the time in Google image search. Image captioning is now labeling, using all these techniques we've got, labeling it with what we think is in the set or in the image. Remember, the labels come from a predetermined set. They're not generated out of nothing, right? So here's some descriptions of images without errors. So the one on the left is pretty good, pretty accurate. A group of young people playing Frisbee, right? This has got small errors. It's only 3 dogs rather than 2. And you get to the far right, and it just completely dies. This is my favorite. A refrigerator filled with lots of food and drinks. No, I don't think so. So part of what's happened here, when you try to debug this, is to figure out what's gone wrong. What's gone wrong is probably the image segmentation, because there's a lot of stuff in there, and the segmenter probably went crazy and did too many things. Now, for you as a UX researcher, designer, how do you understand when this is a low probability thing, right? Answer, you take all the data you've got, including the history of what that person has done in the past, in order to then estimate the likely probability of that interpretation. Works in real time. Very nice combining OCR with object recognition. So you can then do instant retrieval, so you actually can then go to the book immediately. A, recognize that that's an object. B, extract the OCR. C, retrieve that object from your data set. So the question in real world application becomes, where's the objects in this image, right? You might imagine this is somewhere in downtown Rome, right? It's a very well-known monument, but where do you start putting frames around things? So here, we framed each of these objects here. We framed that object. Why didn't we frame that object? Why is that not an object? So the question for building these systems is, how well does it work? And how well does it match your expectation? remember mental models? My mental model is this is identifying all the objects in the scene. Well, I can find objects in there that don't appear in the frames. How do we align that? And so a big question will be, how do you understand these entities and what they're doing? So I've got for you, we've got like a 5-minute exploration to do. So Microsoft put together this vision demo. So what I want you to do is go to that demo. This is probably better on a laptop. There's the URL if you want to do it on a laptop. You can do it on your phone, but you got more screen in a laptop. Choose a demo, work with your group. So here are all the different demos here. Image captioning, classification, sensitive content, so on. Explore it for a few minutes. Think to yourself, if I were doing this for a final project, what would I do? Okay, so go ahead and explore it, and then we'll talk at the end about what worked and what didn't work. You've got 4 minutes now. Go. Does that work?
I mean, you're not wrong.
Yeah, I got it. Oh, that's what's going on. I need to turn my VPN. Sure. There you go. Is it working for everybody? Is it working? Yes. Yeah. Great.
Or maybe it has to be an object.
Wow.
Does it have to be an object or like?
Why isn't this working? There it is. Is anybody else getting this overloaded?
Yeah.
Dang. I can't solve this problem. All right. Do it on your own. Do it on your own. Do it on your own. You would think that they would make sure Azure was up and running, but whatever. So it's clearly hitting a server load. Okay, so let's think about how this works. So for example, in Bing, you click the camera. Unfortunately, the camera icon right here, which it's not a camera I know about, but whatever. You click on it, it tries a visual search. You can bring in an image or whatever, and then you get into the problem of object identification. So I love to look at flowers and try to figure out what it is. And this actually, interestingly, shows a row of ads at the very top. Okay. They got to make money, but what they do, both Bing and Google allow you to grab this frame, and I can zoom in or out depending on what I want to focus in on. For this, it's pretty obvious. For other images, it's not obvious. Look at that picture from Rome. Do I focus in on this monument or that monument or whatever, right? And so that's a focusing mechanism. Of course, the issue is going to be accuracy, right? I've told you before, don't trust it for mushrooms. Forget it. Don't even try. I'm an amateur botanist, so I find lots of problems with this. This one's actually not bad. These are all mallows of one form or another. So this is a common flower in the U.S. Here, if you actually run your mouse into this thing, you can get more data about it, including where it's from. You can save it. You get all these options. And I want to close by pointing out that designing the UX of these AI systems is still really, really hard, right? Especially when it's not clear what the AI is doing. So a fundamental question is, how do we make the UI such that it aligns with our mental model? Here, for example, is my Gmail on my phone, and I'm sending a message to Peter, and this is all fine, but it's giving me a prompt here saying, use your work address. It's not my work address anymore. It used to be. How do I change it? How do I change it? So there's no obvious affordance for this. There's no obvious way to do it. The only obvious thing here is that 3-dot menu, which doesn't, I will tell you, after spending way too long exploring it, doesn't actually give me that option. So what do people do? I go to a search engine and say, how do I change the, right? And in this case, it's particularly hard because what do I call that? How do I change the blank? I don't know what to call it, right? My email address, that's not going to work, right? So you have to be able to describe it like something like my default email address in Gmail on my phone. Fine. Most people don't do it. The reality is people just ignore that stuff, right? Don't be that person.
Do you think that's from Gmail or iPhone?
It's Gmail on the iPhone. Yeah, in this case, yeah. So how do I do it? And I don't know. Okay, so I think we want to wrap up here by thinking about what kinds of perceptual capabilities are we going to see next year, right? When we brainstormed, we came up with things like detecting X-rays that come in from the sky and doing, CAT scans of pyramids. We talked about olfaction. We talked about medical imaging. All these kinds of things. They will probably have AI backends, and the question is, how do you present these to people so they can use them? How do we design with this, and what UI idioms can we use now for this new capability set? Okay, so this is our question for today.